what is a matrix? Okay, so basically you think of a matrix as a table like this. Okay, so you have a table with many rows and columns, and you have some numbers inside it. Okay, so you have, like in this case, you have 4 rows and you have 3 columns. Okay, but because we know vectors already, when you think of a matrix, you can think of them as a 3 column vectors. Okay, 3 column vectors or 4 rows of vectors. 3 column of vectors or 4 rows of vectors. You can think of them in any way, right? But both perspectives are equally valid and give you the meaning of the matrix in various ways. Okay. Okay. Now, in high school, you learn how to multiply matrices, right? But we'll try to do that again today, and try to find some meaningful ways to express that. Okay. So we would start with, but where can you get a matrix? If you have a system of linear equations, you can also have a matrix. Okay. This is what we did previously, right? You can look at this a system of linear equation in column perspective. Okay. So this is the goal that we want to. This is the place that we want to go in 3 dimensions. Okay, and you have 3 variables: x1, x2, x3, and x1 contribute 1 unit to the top, to the first coordinate, contribute 2 units to the second coordinate, and contribute 3 units to the third coordinate. So same thing that as we did previously, but what we did on the exercise, we work on vector with 2 dimensions, but this is in 3 dimensions, but same thing, exactly same thing. Okay. Okay. So you can think of them as here as a row, okay, and then you have a matrix from this linear system like this. Okay. So you have a vector as a variables. Okay. So your 3 variables becomes 1 vectors. Okay. And then you multiply with the matrix, and you get this the right hand side like that. Okay. But how can we interpret this? Okay. When you do matrix multiplications, today we will look at just matrix vector multiplications. You have a matrix, you want to multiply it with the vectors, and then we will look at matrix multiplication later on. Okay. We probably won't have time for today, but when you have matrix vector multiplications, the typical way that we do look at that is like, we start with a row and you multiply a row with a column. Okay, so when you do matrix multiplication, the first, the left hand side and the right hand side, right? The left hand side you look at the rows, and the left hand side, the left part of the multiplication you look at as a column. And when you do this, the first row multiplied with this column will give you 1 times x1, 1 times x2, 1 times x3 equal to 5. So that's the first equation that we have. Okay, so when you do this, you have 1 times x1 plus 1 times x2, 1 times x3 equals 5. Okay, and you can do the same like on the third row. Let's say the third row. So 3 times x1 plus 1 times x2 plus 2 times x3 equal 4. Okay. All right. So this is what we usually think of when we look at matrix vector multiplications. Okay, let me go really fast. Okay, we can look at them by row. So this is the first row. Okay, first row multiply with this vector. You get this. If you have another row, 2, 1, 2, you have that, and then you have that. Okay. So now, when you want to do that as a row perspective, okay, we can think of it this way. You look at the rows and you multiply by this variable x like that. Okay. You have something like that. Okay. When you want to do this, okay, when you have two vectors, this vector and that vector, when you take two vectors and we do the multiplication this way, it's not exactly multiplication, but when we combine in this way by take the sum of the pairwise product. Okay, each guy, the first guy multiply with the first guy on the second vector, the second guy multiply with the second guy, and the third guy multiply with the third guy, and you sum them. This is called a dot product. We have dot product between two vectors. Okay, so in this case, when you do the multiplication this way, you can see that what is the first row. I think this was on the video clip as well, so it's a review. Okay, so if you don't follow me here, you can always go back to look at the video clip from last week. Okay, so the first row is the product between this row and these vectors, and you get the first row. Okay, let's work on the first questions. Okay, so we can view vector matrix multiplication as a dot product. So so we have this matrix, okay, and this vector. Okay, so now the first row is the dot product of this and this, right? So dot product of this is going to be 1 times 1, and then 2 and 3, and 3 and minus 2. Okay, and then you do all the rest. So this is a typical way when we look at matrix multiplications. We can look at them as the dot product between the matrix, a row of the matrix, and the vectors. And what does it mean to be a dot product? We'll look at that next time. Okay, there are a lot of applications that ask you to use dot product. Okay, so the second row and the third row, you can do that really quick. Okay, when you write the multiplication like this, okay, do you see something that you can factor out? Okay, if you look at this this term, you can see that you can there's 1, right, that you can sort of like factor out. Okay, if you factor out 1, what is left? 147. And what is 147? What is 147? It's the first column. So if you factor out 1, you get 147. That's the first column. Okay. Now, if you look at this part, you can factor out 3, right? So if you factor out 3, what is left? So 2. So that's the second column. Okay. Now, finally, you factor out minus 2. Okay, so this is a different way to look at matrix vector multiplications. So it's basically, okay, I'm gonna go a little bit slow here. So you have a vector, right? Or you have a matrix, right? If you look at the matrix, using row perspective, you have 3 rows, right? And the matrix vector multiplication is basically a dot product of each row with the vector. Okay, so the first thing here. But now, if you look at the matrix as a set of column vectors, okay, you have the first column, second column, and the third column. When you do the matrix multiplications, what do you get? So you have this vector, and this vector, right? And what did you do? You scale it, okay? You scale this vector, and you scale this vector by some amount. And you also scale that vector by some amount. And you add them up. What do you get when you have a set of vectors and you scale them and then you add them? What do you get? What is this? What is the result of this? What do we call it? Linear combination. Okay? So it's basically a matrix vector multiplications can be viewed in 2 ways. One as the dot product of the rows of the matrix with the vector, or it can be viewed as a linear combination of the columns of the matrix. Okay? So you have columns. You have these columns. You have these columns. And you also have these columns. Right? And this is the, what do you have? Linear combination of columns. Okay, of the matrix. Okay, 2 ways to look at them, row wise or column wise. Okay.